The main applications of artificial aging in the metalworking industry are mainly in metallurgy, in the manufacture of tools, in also other manufacturing processes, in die casting, and in the aircraft manufacturing. So the main aluminum alloys that are susceptible to artificial aging are aluminum, copper and magnesium, aluminum, magnesium and silicon, aluminum, zinc and magnesium, and the last one is aluminum, zinc, magnesium, and copper. The main conditions that an alloy must have to be hardened by precipitation are to be above solvus 1 phase and below 2 solid phases. The matrix must be soft and ductile. The precipitate must be an intermetallic compound. The alloy must be quenchable, and also it must have a coherent precipitate. So the main mechanisms for aluminum alloys to be hardened are work hardening, solid solution hardening, fine grain hardening, heat treatment, basic heat treatments, edge hardening, solution treatment, quenching, thermal softening, and finally annealing.
So now we're gonna give you some definitions, well, basic definitions of what we have learned through this laboratory. The first one is the precipitation hardening, that is a heat treatment using most of the malleable materials that used to change their mechanical properties into a better way, and also involves most of the alloys used in the industry. The aging is when we want to change the mechanical properties during a period of time. A consistent precipitate is when you need a smooth material involving they have to be in the same phases, all the particles is inside them. And also, well, next is the solubilization and temper. That is when you you go into a higher temperature in a smooth and gently way, and you want to give them better mechanical properties into the material and make them less brittle. Also, we have the natural aging, that is when you change the mechanical properties involving only the room temperature. And the artificial aging is when it's when you go into a higher temperature that is different from the natural aging, and you want them to change their mechanical properties into a better way. But also, this is really important, because if we do not take care of these two definitions, we can have the over aging, that is when you have the material in a long period of time, or also into a higher temperatures than the real temperatures of time that you need. So it will give them loss in mechanical properties. For example, it will be less hard or less strength than the ones that you need.
As we can see in the grain size, the supply, the T1 and the T6 has the same number of ASTM, but the grains counted are different. For the supply, we count 64, the T1 52, and the T6 75. And with the formula that let us know the ASTM, we got for the supply 7.01 rounded to 7, T1 6.72 rounded to 7, and T6 7.23 rounded to 7. That gives us that this is the same grain size, the same ASTM number, but the mechanical properties are different with the Vickers and Brinell hardness test.
As we can see in the table, the Vickers hardness test for the T1 is higher than the supply, So for this test, we can assume that the treatment was adequate, and then for the Brinell test, the hardness decreases, so it's not as adequate as we would like. But because we're more interested in the Vickers hardness, we can conclude that in overall it is adequate. And for the T6, first the Brinell hardness is higher than the supply, so for that instance it is adequate. And for the Vickers, it is also higher than the supply. So in both cases, is the material has a better resistance to penetration. That is what tells us that is very adequate.
As we can see in the tables, the P supply is similar in Brinell to T1 and in Vickers to T6 in the numbers that we have in the hardness test.
So this laboratory practice was really important for us because it gave us an idea of how our alloy of the project worked with the samples that we use in this laboratory, because we could compare the results of this laboratory and the ones that was in the project, so that gave us an idea of how well we got in both practices.
So in this laboratory practice, it was really useful for me because I could see visually and in a practical way the heat treatments applied to the aluminum alloys that were also useful during our final project. So this helped us a lot to understand the main differences between our results in the final project and this laboratory practice.
This practice is, for us, is like little useful because we did the project before we can see the different treatments that we can make to the aluminum alloys. But it's interesting to have all the numbers and know all the different properties that you can affect. In this case, the hardness. If you heat to a temperature, if you did an H or a natural aging hardening.
As engineers, it is important for us to know how the different properties of material can change with the different heat treatments, and it helped us. This practice reassure what we did and what we learned when we did our project with aluminum and the